Hello, everyone, and welcome to Physics 101. In this week's module, we are going to look at a couple of important materials. We'll start by looking at the learning goals for this module. In general, you want to familiarize yourself with the grading system by reading the course syllabus. Also, the communication features on Ivy Learn. I went over a couple of this in the intro video. So if you haven't watched that, please go watch it. Let me know if you have any questions about that. You also want to familiarize yourself with the homework, which will be done through Mastering Physics, and then the lab assignments, which will be done through Pivot Interactives. The materials that you're required to familiarize yourself with to complete the homework assignments will be from sections 1.1 to 1.8, 3.1 to 3.4, 2.1 to 2.4, and 2.8 as well. So these are the topics that we're going to cover from the textbook. By the end of the module, you should also familiarize yourself with how to convert quantities or between the US customary system and then the system international or the SI unit. You should be able to define what a vector is. A vector is any quantity that has both magnitude and no direction. A scalar quantity only has magnitude and no direction. You should also learn how to compute vector components, and so you should know how to do that by resolving the vectors. You also learn about concepts like translational, rotational, equilibrium, and then kinetic and static friction, and how they play a role in how forces work in general. You'll be solving a lot of problems, and so you require the knowledge about Newton's three laws, how to write down the second law, F equals ma, and then how to resolve, again, vectors when you have to look at the various components of forces that are acting in various directions. You should learn how to use the online tools for completing your lab assignments. Be very cautious about the units and conversions as well. And when it comes to graphing, make sure you are giving your graphs a title and then you're labeling the axis with the units as well. At the end of the day, you want to be able to draw reasonable conclusions from the type of analysis that you do with your data and how you communicate your results to others. And so make sure you factor that into your lab assignments with your discussion assignments as well. The assignments to complete for the week would be your introduction. You most likely want to complete this by posting your introduction on Thursday and then responding to your classmates latest by Monday. You don't have to wait till Monday to respond to your classmates. Make it more engaging by responding to your classmates. I've already started responding to some of your posts, so make sure you listen to that as well. Be sure to complete the introduction to mastering physics because you want to learn how the system works in general in entering values, units, and so on. And complete your homework assignments for Module 1 in addition to the lab assignments as well. The final thing I want to show here is what we refer to as a form of a concept map, which I'm referring to as the mechanics mind map. This basically just shows how the various courses we're going to discuss in this course are related to each other. So when we talk about forces in general, we're referring to pushes and pulls, and that's what we're going to cover in chapter 4 in the textbook. And so forces are generally described as pushes or pulls that causes acceleration. We need force to provide the acceleration, and then this acceleration in turn causes motion or leads to motion. Now, this motion includes a linear or translational motion, or it can be a circular motion. And these are all fundamental to understanding how objects move in general. Now, forces can also act over distances. And when forces act over distances, they do work, which ties into energy concepts, which we'll cover in chapter 6. And when forces act over time, they relate to momentum and then collisions, which we're going to discuss in chapter 7. We're also going to emphasize the conservation principles and how we can analyze that. Forces can also act on a lever arm to produce what we refer to as torque, which leads to rotational motion. And that's what we're going to cover in chapters 8 and 9. It's kind of analogous to linear motion. By this time, we're going to look at it in its angular form. Forces can also be distributed over an area, and this results in pressure, which we'll cover in chapters 10 and then 13 to 15. This is essential in understanding fluid mechanics and real-world applications. We can also see that restoring forces leads to periodic phenomena, what we refer to as oscillation and waves, and that's what we're going to cover in chapters 11 and 12. And this will cover things like simple harmonic motion and overall the wave behavior in general. So these show how the topics we're going to cover in this course are linked to each other, and it all comes down to forces and how they are acting, whether it's providing acceleration or whether it's moving over distances, whether it's acting over time, over an area, or in the form of a restoring force. So I hope you find this relevant as you prepare yourself for the physics concepts that we're going to cover over the entire semester. If you have gone through all the materials for the week, then congratulations, you have completed the first module. I may be posting this midweek, maybe around Friday. So my congratulations may either be before or after you have completed the module. But please do feel free to reach out to me if you have any questions. That will be all for now.